Alright, I'm back. I'm working on a 2016 Nissan Frontier with the 4.0 V6. Issue is it'll have a crank no start. Sometimes it won't even crank at all, and sometimes it'll actually crank and start, but all the lights will come on the dash. It'll have major drivability issues. So the guy that had it took it to a local place in Mountain Home, Idaho. Took it to a local shop, paid $65 to get it over there. They plugged their scan tool in. They had no communication with the engine computer. They charged him $100. Sent him on his way. Told me he needs to go to Boise to a Nissan dealer. So he's out $165, and they didn't do nothing to it. So right now, I got the key on engine off. Obviously, that's why the lights on the dash are on. But I did a full system scan, and you notice there I got codes in the tranny computer, ABS, and the all-wheel drive, four-wheel drive computer. I have no communication with the engine computer, which I'll show you in a minute. If I go to report, we have some U codes here. U0100 for the transmission, current status of ignition switch, ABS, U1000 CAN communication circuit, and U1000 again for the four-wheel drive module, and some other vehicle speed sensor codes. So if I go back, just try to communicate with the engine computer here. I have a no comm, right? So pin 16 on the diagnostic link connector is your power to the dongle, which I have. All that's good, but I have no communication here, just like they got. But we're gonna go a step farther and actually try to find the issue with this, not just charge the guy $100 for no reason. Well, I have my breakout box, my 16-pin breakout box hooked up to the OBD port down there. I have it in series to my VCI vehicle communications interface, so I can communicate. So we have no comm, obviously the engine computer. So now I'm going to set my oscilloscope up. I am playing it right now. If you look here, pin 4 and 5 are grounds. You can use either one. Pin 14 is CAN low. Pin 6 is CAN high. So what I'm going to do now is I'm going to plug in the oscilloscope to, I'll just do CAN low right away. So if you watch that screen while it's playing, if I key on engine off, I have a message there obviously. But if you notice the bias voltage, I'll stop that. You rewind here. The bias voltage is like 6 1/4, 7 volts. That's completely wrong. That's supposed to be 2.5 volts bias voltage for a CAN bus control area network. CAN low should go from 2.5 to 1.5 approximately. CAN high should go from 2.5 to 3.5 approximately. The difference of that is the differential voltage, and they twist them in a pair, so if there's interruptions, it's supposed to be a redundancy circuit. But if you look here, obviously I got 6 1/4, 6.5 volts DC, and those messages in there, there's supposed to be a square wave, you know, your zeros and ones, they look, well, all distorted, right? So that's CAN low. Let me go to CAN high. Same thing, right? Should be going up, but it's still 6 1/4, and the message are all corrupt. So obviously we have a communications issue here. I'll start the vehicle. It'll probably start. It does sometimes. So it is running right now, but the bus, that's CAN low again, is still corrupt. You can see it. It's actually got more voltage from the alternator, I suppose, because that's on. Now we're at, like, you know, a couple volts more, 7 3/4 or 1.5 volts, 1 3/4. So that's wrong. If I go back to CAN low, same thing, 7 3/4 volts on the bias voltage. Right there. And these messages, they're completely wrong, right? So obviously, if you look at the dash, all of our lights are on. RPM just lost signal there. You can see it losing signal, coming on and off there. The low oil pressure going on and off. You can see it there. Everything's going whack, right? You can hear the fan once in a while. I don't know if you can hear it in the video. But the fan once in a while will turn on and off, which tells me, I mean, it's not overheating, obviously. I just started it, but it's got a CAN communication issue. Anytime you have a CAN bus issue, it seems like the cooling fan comes on. I don't know why they do that, if it's a safety thing or what. But you can hear the fan on right now. And the temperature is cold. I just started it. It's a little warm, I guess, but not bad. It'll eventually shut off. And I have the AC off too, so the fan should not be running right now. So obviously we got a CAN bus issue. So what I'm going to do now is I'm going to shut the vehicle off. We're going to check pins 6 and 14 with a multimeter. Alrighty, so I disconnected the battery, positive and negative. I got a brand new full charge. Well, it's not a brand new battery, but I did a full charge on it, charged it all afternoon, because it was getting weak when I had it cranked, no start. So I disconnected that, so I'm going to go back into the vehicle and check across pins 6 and 14 with my multimeter, which I have in 6 and 14 there, checking resistance. Right, 60 ohms you should get. Why? Well, these termination resistors in the bus, 120 ohms, use 2 of them, you run them in parallel and you get 60, you know, or 58 to 66, I think is the specification, Nissan even says, or any CAN bus. So we're within our specs right now. That's good, right? But let me go hook up the battery again and I'll show you what happens. Got the battery hooked back up, positive, negative. Let's go back here, look at the, should still be 60 ohms. It shouldn't make a big difference. Shouldn't change it at all, actually. 6 and 14. Well, on the 200 ohm scale, I got an open circuit. Let's go to the million scale, the 20 million scale. I got 13.5 million ohms of resistance. That's pretty much a short, right? That's completely wrong. So if I put the key in, and it's changing there, right? A lot. You put the key in here. If you look there, I just put the key in and now it's reading more than 20 million ohms, or it's open. It ain't even picking it up now. So let me start it. Still nothing. Obviously I should have 60 ohms on that circuit, but I have nothing. And I should never had, you know, 13, 14, 15 million ohms of resistance on pin 6 and 14 when it should have been 60 ohms. When I have the battery unhooked, positive and negative, or just negative, whatever, just disconnect from the circuit, my resistance is within specification. Also, if you remember on the scope here, I'll turn this back on. So it connects again. Let me reset this, hang on. I'm gonna reset the scope real quick. It timed out on me. Get that set up. And then I gotta hook my leads back up. I'm gonna hook my lead here to ground. And I'll just go to CAN low, it don't really matter. See, same exact thing. The bias voltage is in there. You can hear the fan on again. The dash is doing all kinds of, well, it doesn't even read RPMs right now. If I back up a few frames, I passed it. Right there, that bias voltage is wrong. It's like 7 volts, right? Supposed to be 2.5. That's CAN low. Let's go to CAN high. Same thing, 7 volts. Well, if I shut this thing off, watch the bias voltage drop. Drops down a little bit. Fly. But it's still way too high. So what I think's, stupid fly. What I think's happening is, obviously got way too much resistance and we got too much voltage. I wonder if I got to short the voltage on the CAN bus system or something's bleeding over. So what I'm going to do now is I'm going to pull up some wiring diagrams and start troubleshooting this vehicle down. I think they have like a joy connector you can get to all the modules. Maybe pull the modules off the network, check the network lines for shorts together, short to ground, short to voltages. I think it'd be a short to voltage, you know, from something else, or it's internal to one of the computers. But we'll check all that and go from there. I also wanted to show you here, you know, pin 14 is can low, pin 6 is can high. Like I said, these blue lights there, if you can see them, I don't know if you can. Well, they are blue, but maybe not in this camera. Those lights should be flickering on and off, right? Those should be flickering and tell me it's communicating. But obviously that square wave's wrong and the bias voltage is bad. The computer knows that 2.5 volts means don't do anything. It's a recessive state. And all those other little square waves are zeros and ones. Well, when it's getting a higher bias voltage, it confuses the computer and it affects the whole entire bus. That's what's going on right now. The whole entire bus is affected by whatever's happening. So now we got to go troubleshoot it. Alrighty. So what I did is I unhooked the negative battery cable again. This is the engine computer right here. I unplugged. There's 3 connectors. 1, 2. I don't know if you can see the third one down there, but it's pretty dark down there. But there's 3 of them. I unplugged all 3. The bottom one is the one that has, the third one down there has the one with the can high, can low going to the engine control module. So that is the ECM. Right there, we unplugged them all. Got the battery unplugged. Let's go back up. Let's look at our ohm meter. We have 122 ohms, right? Well, that would make sense because there's a termination resistor in the ECM. So obviously I'm picking up with the battery unhooked the other termination resistor of around 120 ohms. Obviously it's a little bit more, there's a tolerance, right? But I'm picking up the other termination resistor in the circuit. If I plug the ECM back in with the battery unplugged, I'll get my 60 ohms again. But this tells me that the ECM, I believe, is good. It's not causing this fault. So let me go plug the ECM back in with the battery unplugged, and I'll prove this will go down to around, you know, 58 to 66 ohms. I don't know if you can see it there. Probably not. It's really dark in there. But the bottom one is plugged back in. Battery still unhooked. Now I should have 60 ohms on the bus with the battery unhooked, or it should be with it hooked up. It shouldn't matter. And I'm within my 58 to 66 ohms. So obviously, when the battery is not hooked up, there's no power going through the circuit. That bus is good to go. So now what I'm going to do is I'm going to unhook that third connector from the ECM again with the battery unhooked. And then I'm going to hook the battery up afterwards and show you the difference. Alright, bottom one's unhooked again if you can see it. Battery's still unhooked. So that means we should go back to 60 ohms. Or not 60, 120 ohms. So we've got a termination resistor out, so we do. Now let's go and hook the negative battery cable back up. Now it's going to apply power through the entire circuit. Now it's hooked back up. I know I got the other connectors unplugged. But if I go to the 20 million scale, it's reading more than 20 million ohms of resistance. Actually, I think I misspoke there earlier. I got the computer, none of the connectors are hooked up. They're all 3 unhooked. All removed, and I got the battery hooked back up. But I'm on 20 million scale. I have more than 20 million ohms of resistance, right? Or open or short, whatever, something's going on here, right? I think I got a short to voltage, I believe. So now I'm gonna have to continue farther and see where our voltage short is. So I pretty much proved there, I believe, that the ECM is not causing the issue internally, which is a good thing. So now what I'm going to do, I'll show you this diagram, what I'm looking at here. That's the CAN bus system for this vehicle. Here's the ECM. They go through this joint connector, all these, this joint connector, these are all different modules, tranny module, you know, differential lock module, your data link connector, pins 6 and 14 on the CAN bus. Well, obviously there's a termination resistor in the ECM, and then one of these other modules have a termination resistor as well. So now what I got to do, I would like to get to the star connector and unhook each one, and then check the bus itself. So I got to come up with a plan how to figure that part out. So I still got the main engine computer unplugged, all 3 connectors. battery positive negative hooked up. We checked the resistance, but what I want to show you now is the oscilloscope, right? So I go in here, ground on pin 4 or 5. I'm going to put the red lead into pin 6 or 14, and I'm going to look at the oscilloscope here. Well, right now with it unplugged, I have 0 volts. Well, I'm going to go ahead and plug it into pin 14. Okay, look, the bias voltage went to 7 volts. Why is it going right to 7 volts? 6.9 volts. If I get those can low, let's go to can high. 7.5 volts. I'm on can high, pin 6. Key is off. What's going on here? I got the engine computer unhooked, all 3 connectors, battery hooked up. I'm on can high, pin 6, key off, not even in the ignition, and I got 7.5 volts when I should have 2.5. If I go to can low, I got 6.9, basically 7 volts, a bias voltage. Let me turn this key on and see what the difference shows. Got key on, engine off. Obviously engine computer's not hooked up. You can hear the fan again. I mean, that could, you know, obviously have the engine computer unhooked, but that signal is obviously corrupt. There's something wrong on the bus itself or another module. So I'm going to keep going down the line, looking at other modules and the bus, and go from there. Sorry, my camera's all over the place. So I'm trying to troubleshoot this and film it at the same time. Alrighty, you can see right now I unhooked the battery and I'm back into can low. But you look at the millivolts, it started at like 400 or 500. It's counting down like from extra voltage bleeding over from, I don't know if it's a module or a short to voltage, but I shouldn't have any voltage right now on this bus. And you can see it's bleeding down back down to 0. Obviously if I had the battery hooked up, key on, engine off, I'd get 2.5 volts, but I shouldn't have any voltage, but it's bleeding down right there. So I don't know, that's just another clue. Maybe, I don't know if there's a capacitor in the module that's doing this, or if it's something shortened to the wires. Again, you got to continue to search for it. I also wanted to check on can high. Same thing, the voltage is bleeding down right there as well. Alrighty, so what I'm going to do now, still got 120 ohms on the bus because the engine computer's unplugged. But I want to unplug another module. Wish I could get to that joint connector, but I believe it's behind the dash. So I could do this without plugging each individual module. But I'm going to go to the ABS module, which is right there on the diagram. I unplugged it right there, and I got the battery unhooked. So obviously, if you see it's still got 120 ohms, that's not a termination circuit on the ABS module. But let's plug the battery in and see what happens. Plug back in. We go up here. Obviously we lost it again. Go to the 20 million scale. Yet again, we have no reading. So obviously it's not that module either. We'll continue on and keep going down the line. So ideally what I want to do is disconnect all these modules and just check the bus circuit, like I said earlier, for shorts to each other, short high to low, short to grounds, and short to voltages, which I think is more of a short to voltage. If this circuit tests bad, I would find it. If it didn't test bad, then it's got to be one of these modules. It's just going to be kind of a pain in the ass to go through each module and disconnect them, depending on the location of them. Alrighty, ABS module still unplugged. I went ahead and unplugged the IPDM, the Intelligent Power Distribution module. Obviously the battery positive negative I have unhooked. I unplugged the IPDM, which is basically a smart fuse box. All those connectors are unplugged. Engine computer still unplugged. I even unplugged, so I got the engine computer unplugged, the steering angle sensor, the IPDM, the ABS module, the differential lock control, the BCM, and the transfer control unit. All those are unplugged with the battery unhooked. If you go up to the front of the vehicle or in the vehicle, I still have on my DLC down here, 6 and 14, can high, can low. I don't have 10 million ohms. I got 10,500 ohms now. It goes from anywhere from 4.5 to 10,500 ohms. With I got about, I don't know, 2/3 of the modules unplugged, or a little bit less, and I still got high resistance on this circuit. So what I want to do now is continue to unplug these modules or get to the star connector. But hypothetically, if I unplug all these modules and I still have high resistance, that tells me something is shorted. Obviously a wire to these can high and can low. If I unplug a module, say one of these modules, and it happens to go away, then I know it's in that module. So we're going to continue to do that. It's just kind of hard to get at some of these other modules. So I'm going to continue on to troubleshoot these modules and go from there. So obviously I'm going to continue to unplug modules or get to that joint connector, but everything was going pretty good. I mean, it still is. When I was unplugging the engine computer, I'd unplug the engine computer, all the connectors, unhook the battery. I'd have, 120 ohms because the termination resistor in the ECM is out of that equation. So if there's not 120 ohms in parallel, you're going to get, 120. If you have two, you're going to get 60. Well, the one termination resistor is in the ECM, which is right here. So I unplugged that with the battery unhooked. I would get, 120 ohms. If I hook the battery back up, I got, millions and millions of ohms. Then I did the same thing with the body control module over there. Same results. But then when I started messing with this IPDM intelligent power distribution module, even with the battery unhooked, this is even before I did the what's the module under the dash, the transfer case module and the body control module, the BCM. Before I even did that, I did this one here, the IPDM intelligent power distribution module. That's when I noticed I didn't have millions of ohms, I had thousands of ohms now. So I'm not saying it's in here, but I wonder if something's going on in this power distribution center. But we'll eventually get to that once we get all these modules unplugged and start checking the can high and can low. So I plugged in the IPDM, all the connectors, intelligent power distribution module, hooked the battery back up, still got the engine computer unplugged, the ABS computer unplugged, but the IPDM is all plugged back in. I did one at a time. And as I was doing that, if you go back and look at the oscilloscope here, I got 5.96 volts. It keeps climbing slowly. Started at a half a volt when we first did this. I got key on engine off. Obviously the computer's not hooked up, but I'm on can low. I know it's getting dark out here, but I'm on can low on my breakout box. You can see it right there, can low on my breakout box, and my voltage is climbing slowly when I plug that IPDM back in, intelligent power distribution module. So if I go to can high, just to see, 6.5 volts, and it keeps climbing. Go to can low, same thing. So why is this not 2.5 volts like it should be? What changed? Every time I mess with it, it's in that IPDM intelligent power distribution module. So I think that's maybe, perhaps, where our problem or issues lie. Also, I put the multimeter back pin in pins 6 and 14 on the breakout box. I'm on the 20 million scale, and I'm reading no continuity, or it's above the 20 million, like I got a short when I plug that IPDM back in. So I still got the breakout box hooked up. I'm on can low, which is pin 14. I'm playing live there. I'm at 6.6 volts. If I go to can high, obviously it goes up to 7 volts, and it'll go higher when the engine's running with the alternator. But I think we're kind of getting down to our problem area. So if you look at that, and we're going to come back up here to the engine bay. I plugged all the IPDM stuff back in. What I'm going to do now is I noticed that this one connector down here, you can see that one right there. That's the one I'm losing or getting a lot of voltage. I'm not saying that's the problem. I mean, it could be on that circuit. I got to look that up. But when I unplug this connector here, so it's unplugged, I go back up here, my voltage drops significantly. I mean, I'm still 1.6 volts, but it's, you know, it's not completely gone. And then if I go to CAN low, because I was on high, then I got 11 volts on CAN high when I unplug it. But CAN low, I have a 1/2 volt with it unplugged. CAN high, I have 11 volts, which I'm not completely understanding it, but we're going to continue on the troubleshoot. So I plugged that plug back in. I showed you that I took out of the IPDM. I'm still in CAN high. When I plug it back in, it goes down, it goes back to like 7 volts instead of the 11 or 12 it was on CAN. And then CAN low goes to 6.6 volts. So then I unplug it again. I'm on CAN high, it goes back to 11 volts. When I go to CAN low, it goes to 1.6 or 1.5 volts. Well, continue to troubleshoot again. Alrighty, so if you look over here at the breakout box, still on pin 6 and 14, everything off, key off. Only thing is I got the battery unhooked, battery negative. I got 60 ohms, you know, 62 ohms on the bus, which we should have. Well, if I come over here to the IPDM yet again, and I unhook that, I believe they call it the C1 connector here, and the battery's unhooked. I unhook this guy down here, leave the battery unhooked, I get 120 ohms, which I expect, right? Because I took one of the termination resistors out. What does that tell me? That tells me from earlier in this video that the ECM has a termination resistor and the IPDM now has a termination resistor. So that tells me the termination resistors are good. So if you take them out of parallel, you're going to get 120. When you put two in parallel, 120, you're going to get 60. So if I plug this back in with the battery still unhooked, plug back in, battery still unhooked, I should go back to 60. Which I do. But now, when I hook up the battery, every module's plugged back in, by the way. I plugged everything back in under the dash, all these modules. So I believe there's an issue with this power distribution or IPDM center or wiring in there or something. I hook up the battery negative. Everything's hooked up. You can hear the key chime. Oh, like I'm out of limits. Nothing. There I got 19 million, 18 million. So I think when it goes nothing, it's going over, because I'm only on a 20 million scale. So if I'm going over my 20 million scale, you would think it's open, but I think it's a short. It's just this meter doesn't go that high, obviously. That's what's going on. So now I will continue to troubleshoot the IPDM and go from there. So I pulled the key out and now it's only at 8 million ohms. It's supposed to be at 60, obviously. If I turn these flashers on, look at it, goes back to 15. Any kind of voltage increases its resistance, it seems like. So I got to continue to troubleshoot.